In tutorial 2, question 1, we have a hydraulic hoist. As you can see in the diagram, it's lifting 550 kilograms. The distance from the point of the load is to the hydraulic cylinder connection on the horizontal arm is 750 millimeters, and then another 500 millimeters to the pivot point of that arm. So we are then asked to calculate what is the force F3. So starting off at 1.1, the hydraulic oil pressure at the piston face of the hydraulic cylinder to just lift the engine. Alright, so that is the hydraulic force in the actual cylinder. So what I've done here is I've drawn a vector diagram very roughly, so you can see we've got F1 is equal to 550 kilograms times 9.81 to give it to newtons. F2 will be operating at an angle, and we can see that that's 65 degrees, that's the hydraulic cylinder angle. But what we're interested in is the perpendicular distance from the pivot point O, which is 0.5 meters to the pivot point. So that would be F2 cos 25 degrees. Right, so taking moments. About point O. All right, so we have F1 multiplied by 0.5 plus 0.75. So that would be the total length of the arm, and that's in the downward direction. Then we've got an upward force of F2 cos 25 degrees and at a distance of 0.5 meters from pivot point. Alright, so F2, we can substitute for F1. So F2 is equal to 550 times 9.81 times 1.25 divided by 0.5 times cos of 25 degrees. So F2, the vertical force, the inclined force in the hydraulic cylinder is equal to 14883 newtons. So that's the force exerted by the hydraulic cylinder, as you can see in the diagram there. So to calculate the pressure, we know that pressure is force over area, and we have the force that's being exerted by the cylinder. The cross-sectional area of the cylinder is pi over 4 d squared, and we're told that the diameter of the cylinder is 50 millimeters. So therefore, pressure in the cylinder is equal to 14883 divided by pi over 4 times 0.05 squared. Gives us a result of 7579.85 kilopascals. So that's the first part of the question that we're asked to calculate. Second part of the question, the number of strokes required from a hand pump with a 12 millimeter piston diameter and a 25 millimeter stroke to give a 200 millimeter extension on the hydraulic cylinder. So that's actually one question there. Looks like two. Alright, so how many times do we have to pump the handle to lift up the cylinder by 200 millimeters? Right, so our pump piston diameter is 12 millimeters. The stroke is 25 millimeters. So the volume delivered equals the volume received. So if we're going to extend the cylinder by 200 millimeters, and we know the diameter of the cylinder, what is the volume required? So that volume is pi 4 times 0.05 squared times 0.2. 0.5 is the piston diameter, and 0.2 is the length that we're extending the cylinder. So that gives us 0.0003927 cubic meters. So therefore, the required delivery is equal to pi over 4 times 0.012 squared. So this is now looking from the pump side, the hand pump side, times 0.025 times the number of strokes, n. So taking n to the subject of the formula, we know what that volume is, we just calculated it, 0.0003927. And pi over 4 times 0.012 squared, which is the hand pump diameter, multiplied by 0.025. That'll give us 138.88 strokes. Say 139 strokes. Right. So that's how many strokes we need to lift the cylinder 200 millimeters. And then finally the force F3 at the end of the hand lever to just lift the engine with the hoist jib in the position shown in figure 2. If the hand lever has a mechanical advantage of 24:1. So this is actually the third part of the question. So we want to know what is the force F3 at the end of hand lever to lift the engine. Mechanical advantage is 24-1, so that's like the lever advantage. So pressure in the cylinder is equal to pressure in the pump, because we have a hydraulic system and the pressure in a closed system is the same. So we know what that pressure is, 7579.85 times 10 to the 3. So the pressure in the pump is F3, also the area, over pi over 4 times 0.012 squared times 24. That's the mechanical advantage. We can therefore work out F3 to be 35.72 newtons. Alright, so that is the end of this question.